Hey, bear with me here. This is going to be the first time I've done a recording of me and the slideshow. So, so far you've seen me in action. We've talked about the stud walls. We've talked about insulation. We've talked about safety with electrical. Today we're actually going to talk about the very basics of the electricity. It just doesn't appear. It comes from somewhere. We have to make it. We're going to go through and show you all this. And I'm going to try not to say so much, but it's me, I guess. So, where does our electricity come from? I'm not just going to read through this. You can read through it with me if you want. But I'm willing to bet that for 99% of us watching this right now, it's consumers' energy. As you get closer down, a little bit south, in Genesee County, a lot of it does come from DT out of Detroit, and that's okay. It doesn't like one's not better than the other. They're both, the power company, and unfortunately, like it's not like you can choose. You can't say, "Well, I want consumers," or "I want Detroit Edison," or "I want." Nope, it's you get what you get. Uh, excuse me. Consumers and DT both create their power from numerous sources. It's not just coal or uh, nuclear or solar or wind. The grid today is very diversified. The companies refer to it as their portfolio, meaning it's multiple things that generate electricity so that they can create that to make money to make, to sell to you or to sell to you to make cash. Uh, Today we're going to talk about those things and, of course, my fun facts along the way. So, power plants. Uh, Fossil fuels are still the most common. Coal, natural gas, oil, they're all used to generate steam and drive turbines to create the electricity. Besides wind and solar, and hydro, well, and even hydro, I'd argue, it uses water. Everything uses steam. We use some type of something to heat water to make steam to drive turbines to create electricity. So even the dams and such that are along the Osable rivers, the Grand River, those generate electricity using water as well. In the same principle, we're using turbines, but instead of water in a steam state or a gaseous state, it is in a solid state, or technically liquid, I should say. So let's talk about coal. Still probably the most widely used, but it's slowly dying out. They pushed for a while this clean coal concept, and no fossil fuels are clean, no matter what they do. They can be more efficient, but there's no such thing as clean coal or clean, fossil fuels in general. So they have their downsides, but everything does. Everything has a downside, a positive and negative. I don't think we'll ever find an energy source that's perfect. Uh, Maybe one day, but probably not in our lifetime. So let's talk about coal. Can you see my cursor? Oh, you should be able to see my cursor. Again, I'm learning. This is new. So coal is pretty simple. We mine it either, from an actual subterranean mine or an open pit mine. A lot of it comes from out in Wyoming range. We transport the coal via rail, and for us, with the power that consumers generates, yes, it can come in by rail, but a lot of it gets taken over to Minnesota because it's a lot cheaper to transport it a short distance from Wyoming to Minnesota, then put it on a ship, Great Lakes freighter, and then transport it over. And a ship too, and we'll get into this. Well, we'll talk about it in a minute here. I'm going to get ahead. From there, they take the coal. It's in basically like softball sized pieces. It gets crushed into a powder, and then they literally blow that powder into a boiler, which then generates steam, and it's intense heat, crazy heat. They then create superheated steam, and I say superheated steam because we know that water boils at 220 degrees. They're heating that water up to 700, 800 degrees, and you're like, well, okay, you're at the point where you're almost starting to separate molecules into hydrogen and making dangerous situations. But we want that superheated steam because water, when you heat it up and make steam, expands so big. So by expanding water into steam, or turning water into steam and then it expanding, you have a lot more force and energy to drive those turbines. So you can see it drives turbines, which are connected to a generator, just like your backyard generator that uses that little gas motor with a generator on the side. Same thing, but this is on a much massive scale. From there, We send it out via those transmission lines to substations, and then it gets bottled down each step of the way to your house. Um, Little backstory: AC and DC power. You've probably heard those two terms, AC, DC, and not the rock band. AC power stands for alternating. If you were to look at it in a stereograph, it actually makes this perfect sine wave, where a DC power is flat. DC power and AC power both can hurt you. The problem with DC power is it doesn't do well because it doesn't have that sine wave. It doesn't do well sending it long distances. So Edison was a big proponent of DC power. His idea was that every block basically would have their own little power station. That's not practical. Westinghouse wanted it to be AC, so they actually, said, look at we can generate this huge massive voltage and send it across, and it'll make it, hundreds of miles if we need to. And then just as we go along, we'll step it down where it needs to be. So AC obviously won out. We use AC today, but it's if you look at the history of how that came to be, it's interesting. Uh, Edison would actually, when they were trying to sell this idea to, the public, it was like the old HD, DVD, and Blu-ray. Well, Blu-ray won out, but Edison was trying to sell this idea of DC power to people, going to communities, and he'd go around, and before he, came and did his little show, he'd have kids gather up stray animals so he could electrocute them using AC power to show the dangers of it. That's crazy. Can you imagine, like, hey, that Edison guy is coming to town. Hey, he's gonna put on a show to show us the dangers of a DC power or AC power, excuse me. Yeah, he's gonna electrify like some dogs. Like, oh my gosh, today that would just be like, that's not cool, dude. You're crazy. But it was a different time back then. And thankfully, AC won because Edison needs to stop electrocuting animals. Coal plant. So this picture that you see right here, this is technically the Carn plant. This is part of an actual, I guess you could say, complex in Bay City, known as the Carn Weddock plant. In the background there, past that water tower, is actually the Saginaw Bay. So the Carn Weddock plant is a dual fuel. You'll see those big tanks out front. It can use fuel oil or coal to then boil water. Hey, look at we got the Saginaw Bay, plenty of water to drive those turbines to make steam, therefore generate electricity. So I say it's the Carn Weddock plant because the actual uh, the Weddock plant was the original. They built the Carn plant. Don't quote me. I want to say in the 60s or 70s. Here's a picture of the actual Weddock plant. So the Weddock plant was built right around. Don't again. I'm not 100% sure on the days. It's 1940s. I want to say, or maybe it could be a little earlier. Um, it's a 100% coal plant. If we take a look here, you see the big smokestacks, and I know you're already looking like, oh, look at all the pollution. A lot of that coming out is actually just leftover steam. Um, Very little soot emission comes out of the coal plants because of the scrubbers and so forth in those towers. It is, as far as burning coal goes, it is as clean as possible. This is obviously taken in the winter. Right now, we're at the boat launch on the other side of the Saginaw River, looking at the Weddock plant. Now, here's a fun thing. I actually got to tour this. They closed down the plant in 2016. A friend of mine who works for Consumers Energy said, "Hey, I can get us in and get us a tour before they close it down. You want to go?" I'm like, "Yes, I would love to see that." So here is how the actual plant works. You can see that water is taken in from the river. That's over here on the left-hand side of the screen. And then from there, it's used in these, well, first of all, we also have coal, and there's these giant boilers. I mean, these things are like 5 stories tall, and they're just blasting coal dust into them, driving that fire hotter and hotter and hotter and hotter. You can see where all the steam is building up, and vented out the top and so forth. It's excess, and actually they condense a lot of the steam. It turns back into liquid water, and it goes into what they call the hot ponds, where it's allowed to cool before they put it back out in the lake. So, and you can see here's the generating floor over here. Take a look at it. It's pretty neat. I found this online. It basically shows you how the power plant's set up. We were able to go in and actually tour the generating floor, or the turbine floor as they call it. That was really cool. And then at the same time too, we were able to go on the other side of these boilers and actually take a look at them. They're massive, and it's just a network of pipes basically inside of a box, and then they make fire inside that box, which those pipes are filled with water. When you boil the water, it generates steam. The other interesting thing was I'm so happy I found this picture. When you walk into that building, take a look. There's fancy trims. And this guy here, this John C. Weddock, as soon as you walk in, his beautiful portrait is there, doing the. So it's kind of intimidating, but it was, this fact, or it is a factory. It's a factory that produces electricity. Was built in a time when people took pride in their work. So you have it's yes, it is industrial. It is, but it's not dirty. Like I never thought to myself like this place is dirty. It was actually very clean on the inside, and a lot of things you're just like this is a power plant. So this is actually inside. These are two massive pumps down here in the bottom that are actually pumping up water from the river to feed those boilers. What the other equipment is, I can't tell you. I just know that those are two massive water pumps. I mean, you can see there's a man lift or a person lift right here, extension ladder down there, just to give you a scale on this thing. And then this is an older picture, but this is the only one I could find of the actual turbine floor. If you notice, there's a basement, and you can see in that first picture that showed like a cutaway of the factory or of the plant. That floor is thick, like really, really thick. I wanted to say they said it was like 10 foot thick of reinforced concrete. These turbines are massive. There's really nothing to compare it to. Well, you can see right here. Here's a scale. That's an entryway for a person. So it just shows you how big these are. And there was actually 9 units, and at one point they were all running at once. When we got there, these units over here, a couple of them have been actually just completely were gone. They sold them to somewhere overseas for a power plant. I wanted to say it was like Saudi Arabia or something like that. They sold them as a power, basically they're still usable. They kept the other ones for parts, and then they only had units 8 and 9 running when we were there because they were basically getting ready to shut everything down, but those were still online. We were over here when we first came in, if you can see my cursor, and the floor was just going, it wasn't like bad vibration, but there was a steady like this floor is vibrating. And they explained like when these things were all running, the floor just vibrated. They're extremely smooth. It's as far as how they run. They had one with the cover off showing all the actual turbine fans. Imagine a jet engine. That's basically what it looks like. It's a jet engine that you force steam through those turbines, and that's what turns. And then your actual power assembly over here. The cast iron housings on these things, so this was all cast iron on the outside, were, I mean, 6, 8 inches thick. It was just like, whoa. And again, it was really neat because look at the floor in here. Again, you have tile floor, and look how clean it is. And that's literally how it was when I visited it. And they were getting ready to shut everything down. Here's the actual boilers. I know it's kind of like I don't really see, but take a look right here. These are hoppers that feed the coal down into the crushers. But then these were the actual boilers right here. They're massive, absolutely huge. Um, 5 stories tall or so, and just hot. And that was one thing you noticed in there. Even with only two of the boilers running and two of the turbines running, it was warm. I think it was about this time. I want to say it was in the spring, and it was noticeably warm in there. Something in the summer had to be really warm. The only other thing in there that was like, there's a lot of it, was everything was marked with this is asbestos, do not disturb. Again, asbestos is a great product as long as it's not friable or up in the air. Pipes, everything like that was wrapped in it because it's a great insulator and it doesn't catch on fire. It really was the miracle mineral minus the side effects of not handling it correctly. Here's a picture of the whole Carnwedock plant. So here's a ship bringing in coal. You can see the pile of coal there. This is the Carn plant. The actual Weddock plant is like the beginning of it is right there in the picture. So they're right together in the complex. They're now pretty much almost got the whole entire Weddock plant torn down. They came in 2 months after we did that tour. They shut down the last two boilers. It's kind of sad. I mean, the plant's been running nonstop, and they'll then come in, remove all the asbestos, and they actually sold the plant to another company that will then take and dismantle everything. And they sold it for all the metal on the inside. There's just tons and tons of steel and copper. Obviously, it's a power generating plant, so they'll come in and scrap it. Uh, Downsides of the coal, and I'm going to start rolling through this so we're not talking forever. They're fossil fuels. Will eventually run out. The bad thing about the pollution from burning coal, yes, in the early years was bad. We can scrub it down, cleaning that up pretty good. The really bad side of it was the ash. You think about it, anything you burn, there's going to be residue. Uh, You burn firewood, there's ash. If you burn coal, there's ash. With ash from coal, there's a lot of heavy metals, lead and mercury. Well, if that seeps into our lake water, that's not good. You don't want to be eating fish that, basically look like a thermometer. So they're still dealing with this. There's a link right here. You can click on this and read. Consumers is still saying, hey, we have a plan for our coal, the ash pile, but there's a giant ash pile in Bay City. You figure they burned coal since, the 40s, and then they're still burning it. So you got to do something with it. It used to be they just, like the old steamships and stuff, they just pushed out in the lake, not a big deal, but that's why we have high mercury levels in some of our lakes. So click on the link if you want to read it, not required. Other things, Palisades nuclear power plant. It is actually owned, uh, not owned by either DTE or consumers, but it's its own entity. It produces power that it then sells to them. It's right on the shore of Lake Michigan on the west side of the state. These towers over here are the cooling towers. Remember, we're taking lake water. We're using nuclear um, fission to generate heat to make steam, to boil water to make steam. Then after we're done with that steam, we cool it off, put it back out in the lake. And this is the intake and outtake rate. Well, intake may be farther out. That's the output. Now, fun fact with this nuclear power plant, you can see the reactor in the middle. Um, I know it's not the cooling tower like on The Simpsons where it's that one giant tower. No, no, this one is that. And those big giant towers like you see in like the Simpsons cartoon, the way those actually work is they pump the water to the top and then it runs down the inside of the tower, and that's what actually cools it. It's kind of a neat process. This one here, though, is interesting because Michigan's it's either the oldest or one of the oldest state parks is the Van Buren State Park, which, oops, let's go to the next slide. Oh, hey, look there's somebody getting in their kayak at the state park. What's that in the background? A nuclear power plant. Yeah, like it's literally next door. So you go to we only had been to as a kid, we had went to the Van Buren once. And I just remember it was like one of those like Michigan 99-degree days. I'm like, oh, can't wait to go to the beach. And then you look over, you're like, nuclear power plant. Like, uh, and it used to be like, you can kind of see in this picture here, but the, the, the hot water ponds that flow out into the lake, it's cooled down to like 70 or 80. But there was kids like boogie boarding in the wake and so forth, and you're like, that's coming from a nuclear power plant. But remember, the way it works is that the water doesn't actually touch the nuclear stuff, so you're fine. It's just made into steam and then so forth, like we've talked about. But now, not going to happen. Um, these are now posted up, and this is not a joke. All nuclear power plants in the United States have this. So, I mean, you're like, well, they can't do that. Yes, they can. Thanks, Bin Laden. So, don't ever try to get into a nuclear power plant because I mean, it's nuclear. They take that stuff very, very seriously. So, enough of that. Ludington Pump Station. If you ever go camping in Ludington, not too far down the lake is this. We have Lake Michigan out front, and then this huge human-made lake up, on a hill behind it. What happens is at night when electricity usage is low, they take pumps and they pump up that man or human-made pond, like basically, and they fill it up. Then when electricity needs to be generated because there's high demand, they basically take those pumps and run them in reverse, and it becomes turbines, and it becomes hydroelectric, just like a dam. So you can see right here in this picture, that's the power plant where they're both pumping at night and then using it to create electricity during the day. And I know you're like, well, that seems wasteful. Believe it or not, it actually generates more electricity than it takes to pump it back up there. You're like, well, that's like perpetual motion. No, perpetual motion means it can run forever with no maintenance. Friction will eventually, wreak havoc on that. But it's an interesting concept. My phone's going crazy. I should have silenced it. All right, and there's a picture too of how it works at the Ludington pump station. Kind of a neat process. Peakers. Hey, everybody's running their AC. It's a hot summer. Our power plants can't keep up. There's these things here, like this one here that you see. It's in Zealand. They're typically natural gas or some type of fossil fuel, and they get fired up. They come online. They can be online in a few hours, and they generate electricity to help support the grid. That way we don't have brownouts, and we always have that 120 volts coming into our house. Whoops, too far. And again, just some more pictures. Like if we had natural gas, it's the same process. Um, take natural gas, burn it in a boiler, create steam from water, drive turbines. It's all the same process. Um, Midland, Michigan has a huge natural gas power plant. It was supposed to be nuclear, but they had foundation issues, like we talked about in class with foundations, and they had foundation issues. And then also at the time, you had some nuclear problem or accidents in the United States, like 3 Mile Island. So people started protesting the building and so forth. It actually bankrupted Consumers Power. They used to be called Consumers Power. It bankrupted them. They had $1 billion with a B dollars into that power plant, and they never recovered from it because they couldn't open it up because the public and everybody just said no. So they filed for bankruptcy and reformed as Consumers Energy. So fun fact on that one. And then they sold the plant to another company, and then Cooperative or something like that. I'm not 100% sure, but um, yeah, it's a giant natural gas power plant. Renewable sources. If you've been out toward the Thumb or out in Gratiot County, you're seeing these. Uh, they do have some downfalls. Sometimes people think they're pretty, other times people think they're ugly. They do cause some problem with birds. There's been videos online, you can Google it, of wind turbine and birds. The birds will use the updraft from these things. Well, you have to remember too, with the wings on these things as big as they are, yeah, right here it's probably turning pretty slow, but then you get out to the tips and it's going at like 150 miles per hour. Um, and the other thing they have too, the last thing I found the research was areas that these are put, there's an increase in suicides. And I think it's actually not true at all. It's just the fact that they're trying to find any data at all to not have these built. The real reason why most people don't want these in their communities is because the companies that are putting them up are LLCs, limited liability corporations. So let's say 20 years from now, these things are junk. Well, if you're Farmer Joe or whoever, and these are sitting on your property, you're stuck with them because the company folded and went bye bye. It's your problem. So that's really the biggest reason why most communities don't want them. My thing is it's like a necessary evil. We're not going to improve on this technology or get better if we don't use it, and there's not a demand. They work. We know they work. They're the wind has to be blowing, but if you find that area where you have good wind traffic, like out in the Thumb or around our lakes, yeah, yeah. I mean, you got we got to do something. We're not going to have fossil fuels forever. And then also don't forget there's solar too. I didn't put a slide up because we should know what solar is. So after we have electricity, we got to send it out to the houses. Here's how we do it. We're going to generate power using whatever method, and then it's generated at super crazy voltages, 765 all the way down to 138,000 volts. Goes to a substation, gets necked down, and then you can see how the actual customers receive it. Big companies like GM and so forth, you're talking they're getting that 26,000 volts delivered to the factory and then divided down even more. Into our own classroom, you probably don't notice it, but we're a primary customer of the school. There's big voltage, like 10,000 volts coming into the class, but there's transformers on the walls that neck it down to that usable, whether it be three-phase 640 or the 12240, which is what most households have, is that 240 volts coming in. And from there, it goes to that meter, which measures your usage in watts. 1 kilowatt hour is 1,000 watts per hour. Oops. And then let's just talk about this real quick. Volts, amps, and wattage, they're all related. A good way to look at voltage is the actual pressure in a pipe. It's a pretty consistent pressure. I don't like that picture. Amps, amps is the amount of electricity actually flowing through there. So we have a constant pressure, let's say 10 pounds per square inch of pipe, but the bigger that pipe is, the more we can flow through. The smaller the pipe is, the less we can flow through, which is where we come to watts. Here's what you need to know about wattage. Basically, we're going to measure, and you're going to be billed for wattage by the kilowatt hour, 1,000 watts per hour. Well, if you have a 100-watt light bulb, that means in 1 hour you're using 100 watts of power, or 0.1 kilowatts. Right now, electricity is right around 6 cents per kilowatt. So I mean, what is that? 6 divided by 10. I mean, that's how much you're paying for using that light bulb. It doesn't sound like much, but pennies add up to dollars, add up to lots of money very quickly. So that's why your parents or whoever you're living with probably says, shut off your light. Make sure you shut things off. Because otherwise, you are just burning. First of all, you're wasting money. Number two, we are burning fossil fuels that we don't need to. Just dig more up. No, we're eventually going to run out. I don't know when, but it will happen. Here's the equation you need to know. And it's pretty much using algebra, we can reverse around. Volts times amps equals watts. Well, what happens if I only have watts and amps? Okay, well, that's pretty easy. Watts divided by amperes will give you voltage. They're interchangeable. There's that algebra thing. So with this being said, the last thing we need to know about is resistance. This is what starts that electrical fire in your house. When you try to pull too much water through that pipe, that analogy, that's resistance. Eventually that pipe's going to burst, and that's called an electrical fire. So when we have a wire that's only rated for, 15 amps, excuse me, and you've got 6 hair dryers pulled into it, well, the pressure is always the same. It's 120 volts. That's not going to change. Well, if you're trying to pull out all that high amperage, in other words, trying to pull out more and more of that water from that pipe, guess what? Eventually it's going to burst. So I hope that analogy makes sense of the pipe and the water. Read through the slide. If you have questions, ask. Here's what you need to do. Read carefully. I'm going to walk you through this. In your room that you live in, your bedroom, I don't care if it's in the basement, the attic, a separate room, or your own house, whatever your room is where you physically sleep every night, I want you to make a list of everything in your room that uses electricity. Think about it. A lot of us have lights. Definitely charge your cell phones. You may have a TV. You may have a lizard, a fish tank. What uses electricity in your room? Don't forget, if you have a ceiling fan, if you have lights on a light switch. Now, an outlet doesn't count. Yes, it uses electricity, but that's a source. What is the actual, we have to get a product, whether it be light, music, whatever it is. What is using electricity in your bedroom? Make a list. Then Google. How much is electricity? How many watts does a phone charger use? How many watts does my 32-inch flat screen TV use? How many watts does my 100-watt incandescent lizard lamp use? Find out the wattage of each. Well, McMullen, they only give me the amps. Cool. Amps times volts equals watts. Then what you're going to do is you're going to add all those numbers together. So we're going to figure out for 24 hours. So what you're going to do is you're going to add all those numbers up. You're going to figure out how many watts everything uses, and you add them all up. That's the total wattage for 1 hour. Once you've added all those up, well, there's 24 hours in a day. So now multiply that number by 24. How many kilowatts is that? Think about it. So, well, as I think about it, follow along here. McMullen has, I'm going to look right now. I got a lamp, ceiling fan, some can lights, and a TV. I figure out that that's 500 watts. Okay, well, there's 1,000 watts in a kilowatt, so that's only 0.5 kilowatts. 0.5 times 24 would be 12 kilowatts in a 24-hour period. At 6 cents a kilowatt, 12 times 0.06 equals how much money? So that's what you got to find out for your assignment this week. Make a list of everything that uses electricity, and next to that, show how many watts it uses per hour. Add up all those watts. If it's more than 1,000, you can, there's 1,000. Well, take that number and divide by 1,000. That'll tell you how many kilowatts. Take all your answers for wattage per hour, divide by 1,000. That'll tell you how many kilowatts. Then take that answer, multiply by 24, because there's 24 hours in a day. Whatever that answer is, multiply by the current price of 0.06 cents per kilowatt hour. Show all your, well, you don't have to show your work, but show me those answers as you go along so I know what you did. If you're still really struggling on this math, shoot me a remind. I can walk you through it. We can meet if we need to through that too, and I can walk you through it. But again, it's pretty simple. Don't overcomplicate it. I know you're like, there's a lot of math. You're multiplying and dividing. If you cannot multiply and divide by now, we have some serious issues. So again, just make a list of everything in your room. How many watts does each thing use? Add up all those together, divide by 1,000. Take that answer, multiply by 24 for 24 hours in a day, then take that answer and multiply by 0.06, which is the cost per kilowatt hour. That will be your final answer then. I think you'll be amazed. A lot of people are like, well, it's only like $2. Yeah, electricity is pretty cheap. However, think about it this way too. 30 days in a month you're going to be billed. So I just spent $60 for leaving everything on? Yeah. And we don't leave everything on. Think about it. You use a light for a little while, you watch TV for an hour. So you're using substantially less. Most houses, like I think our house, we use like $2 a day at most in electricity. And that's for everything. The biggest electricity hog in our house is the electric hot water heater. So is what it is on that one. All right. If you have any questions at all, email me. I don't know how long this video took. Hopefully it's not horrible, but I hope you enjoy it. If you have any questions, email me, or better yet, contact me through Remind. Remember to stay home. Seriously, stay home. Stay safe, and we'll talk to you next week.